Welcome back, everyone. So, what's on the agenda today? We need to do some troubleshooting, some diagnostics on this 94 Miata. I've owned this car for 3 years now, and I've put maybe, let's see how many miles. It's got 68,000 on it, 69. So I put about 15,000 miles on it so far. Yeah, 15,000 in 8 years. That's par for the course in 3 years. So I know the car pretty well. I've done all of the necessary service and some stuff that wasn't even necessary. All age-related issues and mileage-related components. I only use OEM parts. That's all I buy. And I buy them from legitimate sources. I do not look for the cheapest thing on Amazon or eBay. That is not how I do it. Unless that is the only option I have. Unfortunately, I haven't had to do that. So I'm not the kind of guy to just take out the parts cannon and just aim and replace everything in its path. That's not what I do. But what I did do with this car is when I bought it 3 years ago, I just started getting caught up on all the maintenance, fluids, filters, everything. Right now this car is 100%, but there's one problem, and that's why we're making this video. The one problem that this car has developed very recently. Now, I should take you back a little bit, because back in last summer, it started developing a problem only on warm starts. Only on warm starts. Never any other time. It would stumble and nearly stall until you let it run for like 30 seconds to a minute. And then it's fine. Goes good. Goes great. Doesn't stumble. Doesn't sputter. And I determined that that is a bad coolant temperature sensor. In my case, the sensor, it actually passed. I checked the resistance on it at room temperature, and it was, I believe it was within spec. But as the temperature rose, it did not follow accordingly. So I went over to the Mazda dealer and I bought a legitimate OEM Denso sensor to replace it with. Ever since then, the problem has been completely solved. No issues. Now this problem is different, and I'm going to try to walk you through my steps, and we're going to get to the bottom of it. Okay, I forgot my tripod, so we'll make do. Here's the situation. Take the car out in the morning, on a cold morning, warm morning, whatever, doesn't matter. As long as it's been sitting overnight, at least 24 hours. Start the engine, and it cranks and cranks. Yesterday, it was the worst I've ever seen it. It took probably 4 or 5 seconds of solid cranking, and it did start. And it ran perfect. Stumbling, nothing. Shut it off. Start it up again. Starts right up. No issues. I haven't started it today, which is why I'm starting the camera now. We're going to get that on. We're going to see how long it takes to start this time. It's been sitting overnight, 24 hours at least. But let the car sit for more than about a day or so. That's what happens to it. Now, I did a little bit of research. I watched a couple of other YouTube videos, and here is what I came up with. And I was suspecting this, actually, when the problem just started about 2 months ago. I was suspecting this but I didn't really know. I didn't look at a fuel system diagram to see how all the components are connected. But I do know that Volkswagen products from the 1980s, that was my first car, I had a GTI, 87 GTI. The old Bosch K-Jetronic fuel system and other systems, they use what's called a pressure accumulator, a fuel pressure accumulator. And what it is, it acts like a ballast. It's a little canister that pressurizes with fuel, and it can maintain that pressure under, I believe there's a spring-loaded mechanism in there that keeps it under tension or under pressure. And what it does is, when you start the car cold, the fuel pressure is already up to spec or up to a certain point. Fuel pump kicks in, engine fires up immediately, and all that should work together in harmony. So the fuel pump, by the time it's fully online, the engine's already started and everything's all good. When the pressure accumulator fails, or when it gets removed and bypassed, the fuel pressure bleeds down when the engine's shut off, and the engine takes a lot longer to start. It just cranks and cranks, and as the fuel pump is building up pressure, eventually it starts. So what I learned is that the Miata fuel system, which was probably designed by Denso, I think, the Miata's fuel system doesn't have a pressure accumulator. It actually uses the lines as a pressure vessel. And it has a check valve in the fuel pump. When the engine's shut off, that check valve prevents fuel from flowing back into the tank, and it remains under pressure. There are 3 ways that this kind of an issue can occur, and it's usually one of these 3 things. Sometimes it could be 2. Maybe it's all 3, but we'll just stick with one of the 3. So the fuel pressure is held back by 3 mechanisms. The first one is the check valve in the fuel pump. The second one is the fuel pressure regulator. The fuel pressure regulator is this little canister right here. Okay? And that appears to be vacuum operated somehow. I don't know how that works, but there's a solenoid that controls vacuum flow to that for some reason. This is the fuel pressure regulator, and if it fails, it can, or if it's in a failure mode, it can allow fuel pressure to bleed off and end up back into the return line. So the fuel pressure regulator connects to the fuel return line. The way this system works is when the engine is running, the fuel pump is kicking, and it's pressurizing the lines to be well over what the fuel injectors require. And what that fuel pressure regulator's job is to basically say, okay, I need, let's say, 40 pounds of fuel pressure. Let's say I'm getting 60 pounds. And they're all made up numbers. These are not real numbers, but I'm going to take that extra 20 pounds of fuel pressure and I'm going to send it back to the tank. So it opens up just enough to keep the pressure at spec, which is, I believe, 40 pounds. I will check that in a minute. And it appears to be regulated by vacuum, but we'll have to figure out how that actually works. But it sends the fuel back through this hose here, through this pipe here, and that pipe goes under the fuel rail, or under the intake manifold, and it is this guy right here. Okay, this is our return line. Now the other line, this is the pressure line. This is the one that feeds the fuel rail, and it comes up, it's actually this one right here, the one on the bottom there, and it goes up through here, enters the fuel rail at the end, right about there, and it pressurizes the entire fuel rail. Like I said, if the fuel pressure regulator is defective, it will allow fuel to seep past it even when the engine's off, which it's not supposed to do, and you will lose fuel pressure. Now let's talk about heat soaking for a second. When you park the car in a garage, hood closed, after driving for a while, everything under the hood is hot. Everything's hot. You can't even touch it. Now, what that does to fuel wants to vaporize. It wants to expand and become a gas. Vaporize, basically. And that heat, if the fuel is not under any amount of pressure, that heat will cause the fuel to basically boil off. And it pressurizes and it goes right back into wherever it can go. It can go down the return line. It could go down the supply line. That's if the check valve is bad. Or it can go through the injectors. We'll talk about that next. But that condition is called vapor lock. And that used to happen all the time, back in the old carbureted days. And it was often mitigated by heat shields and better engineering, but for some vehicles, it was just a fact of life. Vapor lock was a problem. You go to the store, nice hot summer day, you're driving down to the store, you park your car, shut it off, and you go back to the car after you get your milk and Kahlua or whatever, and you start the engine, and it just cranks and cranks and cranks. And then eventually it'll start, because it has to replace all the fuel that's boiled off. I mentioned fuel injectors. That is the third way we can be losing fuel pressure. Now, let's backstep a little bit. On a functioning fuel system, when everything's perfect, the fuel is kept under pressure, which prevents vapor lock from ever occurring. Think of it like liquid propane gas. When it's under pressure, it's in a liquid state. It remains that way. As long as it's under pressure, it's a liquid. Once that pressure is relieved, it has the freedom to do whatever the hell it wants, and it becomes a gas. Kind of, sort of what's going on here. Well, actually, a better analogy would be the coolant in your radiator. Under pressure, that coolant cannot boil. As soon as you take that cap off when it's hot, it's going to immediately start to boil. And it boils right through, or it escapes right through the cap, because that's what it wants to do. It wants to boil. But when you keep liquid under pressure, it can't boil if the pressure is high enough. There. Okay. So, fuel injectors. We have 4 of them. And if any one of those 4 fuel injectors doesn't properly seal when the engine is off, or when the valve is closed, the needle valve and the fuel, or the fuel injector, the solenoid valve, when it's closed, fuel cannot escape. It remains under a pressurized state. If one of those injectors is going bad, you will have fuel slowly drip out of it when the engine's off. But that's easy to diagnose. In fact, the easiest way to diagnose that is to just start the engine when it's cold and look at the exhaust, or sniff the exhaust, if you will. And by doing that, you're looking for obvious signs of a rich condition. You're going to see black smoke. If it's bad enough, you'll see black smoke, or you'll smell a lot of unburned fuel getting into the exhaust stream. And that's how you'll know. But there's a better way. Now, the better way is to use a fuel pressure test kit. I've never actually used one. I'm going to be straight with you guys. I've never used one. I bought this at Harbor Freight. This kit cost $50. There is a cheaper one, but they didn't have that one. They don't sell that one anymore. Not at the store I was at. They told me they discontinued it. This one is $50 and includes all the fittings, everything you're going to need to check your fuel pressure on most vehicles. Now, like everything Harbor Freight sells, it smells like cancer. But it's either this or a snap-on tool that cost $1 million. So, you know. Okay, so what do we got? I don't think we're going to need these. We don't have Schrader valves on our fuel system. The Miata uses just old-fashioned clamps. So we're going to be using this right here. And it's designed so that you can disconnect the gauge from this, and it should still maintain pressure. At least that's the idea. This fits 2 different sizes. Now, this is really cheaply made. It is aluminum. But whatever, as long as it works. And you get these little hose bits. We're going to probably need those and some clamps. So I'm going to go ahead and we're going to start the engine. We're going to see how it starts right now. That way you can get an idea as to what we're dealing with. So I'm going to park the camera right here, and we're going to start her up and see what happens. Now, as I turn the switch to the on position, I'm going to silence the buzzers and everything. I suspect, because I noticed yesterday when I was kind of messing with the car, I noticed I wasn't hearing the fuel pump priming, which you should hear the fuel pump relay click on and off. There's a possibility that we could have a bad relay.
I just want to correct myself. I later learned that the system works like this. When the ignition switch is turned to the on position, it does not prime the fuel pump like most cars do. it primes it when you're in the crank position, and then when the ignition switch is released to the on position, the pump continues to run until it's shut off. There is no priming at all in the on position before start.
Okay, he's going in. Okay, the fuel pump definitely made noise. Okay. All right. That time it ran fine. So that's something. That's special. Well, you know what? We're going to continue on. This could be this could get very interesting. I'm going to grab a couple of rags to soak up the fuel as I go ahead and drain the not drain, but I'm going to relieve the pressure in the fuel system. What I'm going to do, we're going to take this clamp off. We don't want that fuel going anywhere. We're going to also remove the fuel cap, and that's going to remove any air pressure that's built up in the tank. This is a sealed fuel system, so it does hold pressure. I put this there so the seatbelt wouldn't go off on me. All right, here we go. And that, another thing, when you take that off, make sure that's air coming out, not going in. Because a clogged PCV valve or tank ventilator, whatever the hell they call it, tank vent valve, could cause the fuel tank to go under vacuum. So you want to make sure that that doesn't happen. It's all part of the process. So I'm going to remove this hose clamp, and I'm going to attach our fuel pump pressure tester. All right, we got our gauge hooked up.
So the clear hose is for purging the system of air so you get a more accurate reading on pressure. It's also used for relieving pressure when you're removing the gauge from the Schrader valve, and for draining the system out when you're done using it. You never want to store these with fuel in them. It's probably not a good idea to do that.
So we got to prime the pump and see if it holds pressure. All right, it's going to be hard starting, so. Okay, now we got pressure. All right, let's check for leaks. We got no leaks so far. Everything looks good. Engine's running fine. We got 32 pounds. I think that's a little below spec. What do you think? That's a little low. I believe it's supposed to be 40 pounds. But then again, we've got a Harbor Freight gauge. How accurate is it? We don't know. Now, if I rev the motor a bit, it actually does go up. The pressure regulator seems to be responding. You know what I think it does? If the vacuum drops, it sees that as an acceleration, and the pressure regulator responds by raising the pressure. Okay, that's actually good to know. Now what I'm going to do is I'm going to run some fuel out of that line. I want to make sure that there's no air in the system, so I'm going to do this. Make sure it goes in the tank. All right, so we got no air in there now. All right. So now we're getting 35 pounds. I'm going to check the Haynes manual and see what it should be. Of course, I don't want to asphyxiate either, so we'll open the door. I just turned the engine off a second ago, and we're looking at fuel pressure drop. It was at 35 pounds when running, and now it's at 30. So it is slowly dropping. Not enough to be alarming. We don't have any leaks. That would be pretty obvious. So We'll just give it a few minutes. I'm going to look for that manual. Oh, there it is. Look at fuel pump pressure maximum 70 to 95, idling through 96, 32 to 38. So we actually are within spec. Fuel system hold pressure 92 and on should be 21 pounds. So that is the hold pressure with the ignition off. It should settle down at around 21 pounds at a minimum. Idling 29 to 35. We are within spec. So if we had just gone on to Amazon, I'm just using my favorite online store. If I go to Amazon and buy a $29 fuel pump because I think it's bad because, you know, this is all happening. If I were to have done that, I would have taken out a finely crafted, albeit old, but finely made, long-lasting fuel pump from the tank, and I'm going to put in something made in a sweatshop in China that's going to last half as long, if that. If I'm lucky, I might get a few months out of it. And I'm going to throw away the perfectly good OEM pump that has nothing wrong with it. This is why we diagnose things. This is why we look at the manuals, which is why we buy the right tools and we look at the data, see what's really happening. Now, the unfortunate thing is, all of this has been completely inconclusive. The symptoms all point to possible loss of fuel pressure. A couple of things I just learned. It turns out that the system is holding pressure just fine. No issues at all. So that is, we're going to start it up a little bit, run it. Maybe let it reach temperature, then I'm going to shut it off and see where it holds there. But preliminarily, it looks like our pump is fine. Check valve is checking. Fuel pressure regulator is regulating. The numbers are well within factory spec. The other thing I learned is that there is no fuel pump prime circuit. So it doesn't activate the pump for any length of time when you turn it into the on position. The fuel pump doesn't start spinning until you are in the run position. And what's more, because it doesn't have a priming circuit or a priming mode, it depends on the system remaining under pressure. Go figure. So, I don't know. What I do know even if I bleed it off while it's running, it's got good flow. Appears to anyway. Rebounds. What do you know? Like, go figure. I think I have it nailed and I'm wrong. So, what are we going to do? What do you think we should do, guys? Today it's not acting up. It's bumping the pressure up as it's supposed to. Now, there's another test you can run with the vacuum line disconnected. That's this one right here. Now, with the fuel pressure regulator, vacuum line disconnected, it goes up a little on the high side. It's at 40 pounds. And if I, hold on. All right, let's see if I can do this with two hands here. I'm going to block off that, and I'm going to blip it. got good pressure. Plug this back in again. Now the fuel pressure regulator should be taking over and dropping it down to like 30 pounds. But it's not. Now what if I bring the...
I think the reason it's not bringing the pressure back down again is because it's still within spec. So that's probably totally fine. And I bet over time it would bleed down naturally and then maintain that 32 or so pounds.
And that was different. That was interesting. When I disconnect it, the pressure goes way up, but when I plug it back in again, it doesn't drop down. Well, maybe it takes time. Yeah, it's coming down, but you would think once it's at a certain point, you know, it's possible that our fuel pressure regulator could be going out. But that's hard to say. It is holding pressure, so that means the entire system is holding pressure. So let's say let's just say that the fuel pressure was bleeding off, which it shouldn't do. It should go down to like 30 pounds or whatever and stay there, or 20 pounds. But let's just say it bled down to 0. We would want to eliminate the pressure regulator from the pump. One of the two now, or one of the two areas of concern. So what you're going to want to do is pinch off a line. So shut the engine off, and you're going to pinch off your supply line. That's this guy right here. That's the high pressure line. And no, I'm sorry. We're going to pinch off this one. That's our supply. This is our demand. So you want to pinch this off with one of the, I have over here somewhere, I've got a line pincher. And then you're going to see if it's bleeding off. Still, the fuel pressure is still a little on the high side. Now this tells me that engine idling, vacuum hose disconnected from regulator through 96, not specified, but should be approximately 5 to 10 pounds greater than with the hose connected. So guess what? Now originally the fuel system hold pressure on the 91 was 50 pounds. 92 on, it's 21 pounds. Again, everything is well within spec. Everything else is good. We've checked all these things. Everything's fine. What are you going to do? So I think that's enough playing around. I'm going to shut it off, and we're going to see where it settles down again. Now, there's another possibility that just occurred to me. It could be that the fuel pump relay is indeed bad. That is still a possibility. It could be going out. Now there are ways to check those. You have to bench test them. The fuel pump relay is one of these two relays. There's one relay. It's fuel injection. I suspect. Oh no! No, the fuel pump relay is actually under the dash. I'm sorry. That is where it is. It is under the dash. That is a fact. And then what you'd want to do is pull the relay out and then bench test it multiple times, and then you would be able to figure it out. Of course, a relay is what? It's an electromagnetic switch. You know, you've got your low power side, which is your coil side, and when you apply power to the coil, the switch closes or opens, depending on what kind of relay it is. In this case, it's probably normally open. So you apply
of all the possibilities that I've thought about, a fuel pump relay could actually cause an intermittent fail to start. That is a possibility. So we're going to keep an eye on this for a little while and see what happens. But what could happen is the relay could fail to close completely, occasionally. So that's not a possibility that I've ruled out at this point.
I'm going to bleed it off. I'm going to disconnect my tool, and I'm going to put it back together again. Now, this is a Schrader valve. It shouldn't leak too badly, but we want to drain the fuel out of this guy. Let me just... little tidbit to anyone who owns a Miata, regardless of what year it is. But this is especially important for the older models, especially the NAs. They rust out right in the quarter, right about here. And the reason they do that is the drain holes get clogged with debris. So, what you want to do on a regular basis, maybe every time you wash the car, think about doing this. Take a garden hose and then spray the top and look for where the water's coming out. Might take a second. See that stream back there? That is your the drain hole, sorry, for the top assembly. That is the drain for the assembly. There's like a pocket back inside the body cavity, and if water pours cleanly out of that hole, then you're in good shape. But if it doesn't, and that means you've got water backing up, or if it comes out very poorly, like in a drip, you've got debris that has to be removed. If you don't take care of it now, you're going to be replacing body panels later. Now I'll check the other side. Now the fix for that, if you do have plugged drains, then you've got to remove the entire top assembly completely. The whole thing has to come apart, and then you can unplug that drain. But I see good flow here too. And kind of reach up in there. Oh, there's some debris in there. Yeah, so some of that's getting flushed out. There's a rubber hose up inside there. And you can kind of feel around. I can't show you with the camera, but kind of feel around it and make sure it's not punky. But yeah, there was a leaf stuck in that one.
Now, just to reiterate, if it is completely blocked and there's really nothing coming through water-wise, I would probably take the entire convertible top assembly out and look down in there from the top and clean it out and check for any major corrosion or body or any major damage. But if it's just partially blocked, like mine was, just pull out what you can and you can make a hook out of some stiff wire and stick it up in there and pull out any leaves or pine needles.
Yeah, the other one's fine. Nothing's stuck in there. They get completely blocked, and water and debris. It turns into a mess, and it just rusts out the whole car. The other thing, and if you ever have an opportunity to remove the wheel liners, this car was actually pretty packed with mud, but up inside here was all full of mud, and I had to very gently remove what was there. There was no rust at all. I got really lucky on either side, no rust. So what I did is I cleaned it up really well, and then I sprayed some fluid film inside the cavity to give it some protection. So, two things you want to check for. So before we close out the video, I want to just do one more quick startup test, see how it goes. So the car, I drove it to work on, I think it was either Friday or Thursday. Today is Sunday afternoon, and I haven't driven the car since. So it's had a good amount of time to just, do whatever. I still stand by my theory that there is a fuel pressure loss over time. I don't know what's causing it because our test was clearly inconclusive. I do suspect that the check valve in the fuel pump could be to blame. or the fuel pressure regulator. I don't think it's injectors. We pretty much, I mean, those were fine when I last looked at them. So let's just see if it's done it again, shall we? Okay, either I have this turned off. Okay, that's like my battery's dead. What? All right, let's see what she does. Clutch in, neutral. Okay, now that wasn't bad. That wasn't bad at all. Started right up. No issues. Okay. So what have we learned? Well, that in order for the fuel system to work without a priming circuit, it depends on residual pressure in the lines from the previous run. Makes sense? If that pressure is ever lost, if it bleeds off, it takes the fuel pump a little bit longer to build pressure once you start cranking the motor. I can't think of any other explanation as to what I was experiencing. And being an intermittent issue, definitely going to take a look at that ECU though. I think at the end of this season, when I put the car away, I'm going to pull the ECU out and we're going to have a look at that. Check it for any bad caps or any obviously bad caps. I may just replace them. I think there's only a couple on there. So I do suspect that might be a, if it's not a problem now, it could be a problem in the future. And if you've worked on electronics for any length of time, especially older electronics, you know that capacitors can fail in very innovative and unexpected ways, and they can cause further damage. So that is something worth looking at, especially given the age of the car and the rarity of that ECU. A 94 ECU is hard to find. They only used them, I think, that particular ECU, I think, was only in 2 model years. And it has to be a manual car, not an automatic. So it has to come from another manual car. So yeah, that's a whole nother ball of wax. But anyway, it started right up. So I think we're okay. I don't know. Maybe it was a fluke. It could have been a fluke. Now the car had been sitting for a little over a week. And so that, you know, that does have a factor, I think, in this whole issue. So, well, that's going to conclude our video. Thank you for watching. And now you know how to check for fuel pressure. We learned a little bit about how the fuel system works in the Miata. And hey, if this helps another fellow Miata owner, great. If not, sorry I wasted your time. Okay.